All right, Calc 1, you are watching this video because I have had a baby. I'll give you details about the baby and everything. Hopefully the baby's healthy and all that, because I'm recording this before I have the baby, so I can't really give you details of gender or name or any of that sort because it hasn't happened yet. I'm just trying to be prepared. All right, so today we are going to be looking at slope fields. This is a new chapter. I hope you had a great break, Thanksgiving, a good relaxing break, and now we can jump into a new chapter. This is a short chapter. It's a 1-week chapter, and if I'm gone, I'm going to be gone for a lot of it, so I'm going to try and do it through video lectures. So hopefully this helps. Slope fields, what they are. Here's the idea. In the DVA world, I'm going to start us with the V. I'm going to give you everything about the V, which means, yes, in one world you can think I'm giving you velocities, but for right now I want you thinking I'm giving you slopes. I'm giving you tons of details about the slope of this story problem. And everything I'm going to frame it in is a railroad track. So I'm giving you possible ways to design a railroad track. Those are all those little slopes. And from that, we are going to be able to line up a railroad car and the actual route it goes by being able to integrate that slope field. Because if you can integrate the world of V, you get up to D. So you actually get a possible path. Now, if you remember, when you integrate, you always integrate and you say plus C at the end. So if it's a plus C, there are many options for this railroad track and this railroad car. So if I give you a specific town or specific point that I need you to go through, then you will be able to plug that point in and solve for the C. You really know how to integrate up, how to get the plus C, and then you also really know how to figure out who that C is. It's just the idea of the slope field and how it represents the possible routes the railroad car can go. So the sub hopefully has passed out the worksheet today that we're going to follow along with, and we're going to take a look at the first page. In the first page, it talks about there are 4 slope fields that I need you to draw, and we're going to do one together. So we're going to do the dy dx equals x plus 1, and you have a little grid here, and I want us to set up all the tick marks to help showcase what the slopes are. So over here is going to be my slope field. I'm going to write it in blue to remind you that we're in the V world or the velocity world or the derivative world. Now, what it is just saying, all right, let's plug in any point we want and let's figure out what that slope is. So if I plug in at 0, 0, I want you to physically plug into here at 0, 0, what do I get? Well, dy dx at 0, 0 would just be 0 plus 1, which is 1. Which means at the origin, I want you to draw just a small little tick with a slope of about 1. Okay? And then you can do it again. So you can kind of erase, because you don't really need all of the work. I just care about the ticks. And you can say, okay, let's try at 1, 0. What I get from my slope. Well, dy dx would be 1 plus 1, which is 2. So now I know at 1, 0, I'm going to go and I'm going to make it just a little bit steeper. Okay. Now, I don't know if that's exactly a slope of 2, but you kind of get the idea. That's what I'm hoping to draw. And you could do it again at 2, 0. I think you're getting the point here. At 2, 0, the dy dx would be 2 plus 1, which equals 3. So then now it's even steeper. Okay. Now my goal would be to fill in the whole chart. Now you might say this will take an extremely long time, but I want you to notice something. This dy dx only has x in it. So the slope creator, the slope field, only has x's in it. Well, I plugged in 0, 0, and I got a slope of 1. If I plug in 0, 1, it's a new point, but is the x the same or different compared to 0, 0? So again, here's 0, 0. Here's 0, 1. I could do it again here at 0, 2. I could do it again here at 0, 3. All of them have a new y value, but the x value is the same. So when you plug in those points, you should realize that it's only x plus 1. Well, if all of those x's there are 0, 0 plus 1 gets me a 1. So now I've learned that everywhere up here has a slope of 1. And everywhere down here has a slope of 1. Now you might be asking, okay, you're putting them on the tick marks, kind of on the nodes of the grid. Could I put one at 0, 1.5? Yeah, you could. Because can you plug in 0, 1.5 into this little formula, and you still get a 1. So any point you want to do, you can plug it in and get a little arrow, per se, a little slope part. Now, that 0, 1.5 you can have there, but I'm only going to do it on the grids, on the little nodes, just to kind of keep it a little bit nicer. So likewise, everywhere on this section here that I'm highlighting, what's true about the x value? The x value is 1. So if x is 1 everywhere here, when you plug it in, you get x plus 1, or 1 plus 1 is 2. So everywhere here, your slope is going to be 2. Everywhere here, your slope's going to be 2. Likewise, everywhere here, the slope's going to be 3. And at 3, when x equals 3, this whole last kind of vertical line, 3 plus 1 is 4. So it's even steeper. So now we're kind of getting more slopes laid out on my grid. Now let's look. Let's kind of, I'm going to keep this red line for us and just say, okay, everywhere here, what's true about my grid? The y's change. They change immensely. Positive, negatives, all of that. But the x is always negative 1. So if x is negative 1, negative 1 plus 1 equals 0. So every place here, that dy dx is getting me a 0. So I have that. Here, everywhere there, x is negative 2. So negative 2 plus 1 equals negative 1. So everywhere here, my slope is a negative 1. And the last guy, my slope would be a negative 2. And if you notice, I have no idea if this really looks like a slope of negative 2. It's just, at least it helps me see that it was steeper than the negative 1 slope. Okay? So, from that, what we have just done is my first step that I told you, and I'll slide back so you can see it. The first step was the blue step. I'm going to give you a slope equation, which is called a differential equation. And we're first going to draw little lines representing the slopes at specific points on a grid. Literally, we plugged and chugged every point that's a node, figured out what that number was, and declared it a slope, because this is your slope equals x plus 1. So just plugged and chugged. Okay? Now, from this is what this means. If I decided to be a railroad, and I'm going to have an engine right here. If I put my engine right there, and I say drive, engine drive, chugga chugga choo choo, then it is going to follow the slopes that we've created. So it might go down, it might dip, it flat lines there because everything there is flat, and then it's going to come back up. So that is a potential route for a railroad. I could also start lower, and maybe I start down here at that place, and it's going to follow a steep slope of negative 2, then a negative 1, then it flat lines, and then it comes back up, and you have that path. And we could do one more. I can make it a little bit lower. And it seems to follow the same general shape of something like that. So the whole thing is, I want to know exactly what that path is. They all look like parabolas, but I want to know exactly what that path is. And let's say I have the point here. Let's say I'm using the point, this green one here. And let's say it looks like I'm going through the point negative 2, negative 1. That looks like that's on that green parabola. So I want to know exactly that green parabola. I want to get it. Okay. So the way to get it is what we're totally used to, is integrating. Remember, this function here is dy dx is x plus 1. You can think of it as y prime is x plus 1. If you're in the v world, if you want to go up, you need to integrate. Now, I want us to get used to this notation so it doesn't feel weird to you. On this dy dx, I'm going to start it again. I want us to get used to this idea, and it shouldn't be too groundbreaking. I want us to multiply both sides by the dx. So I'm now going to write it as dy equals x plus 1 dx. And the reason I want to write it this way is I want you to get used to this formatting. When I say I'm going to integrate, I want to integrate both sides. Now that right side should look very familiar to you, where it's the integral of something dx. That's what you've been doing integrals about the whole year. And you can just integrate that very directly. That's going to be 1/2 x squared plus x plus c. Now the left side, you're more used to having dx's, and this one has a dy, but you can do it. What's the integral of 1? There's a 1 right there. What's the integral of 1 dy? Well, it'd be 1y. It's not x right now because it's in terms of y, so the integral of dy is y. So I now have y equals 1/2 x squared plus x plus c. I want you to realize what that means. That here is the general shape of any railroad car as it goes through that path of the slope field. And if you look at the red one, if you look at the green one, if you look at the black one, those are parabolas. And it's a happy parabola because it's a positive 1/2 x squared. Every single one of those is the exact same parabola. It's either shifted up or shifted down. And so if you need to figure out what shift it was, how high up was it or how low was it, you can plug in a point. So the point that I want to fit is the -2, -1, so we can plug that in. So I could say, okay, -1 equals 1/2 -2 squared plus a -2 plus c. So now I have -1 equals -2 squared is 4, half of that is 2, minus 2 plus c. -1 equals c. Oh, okay. So then now that means if I want that path specifically, it is y equals 1/2 x squared plus x minus 1. And that would be the path that my railroad car, my Thomas the engine, would follow if it had to go through the town -2, -1, and it's forced to go through this slope field. And remember, that slope field is just creating the general path because it's giving you little ticks, little slopes of what you're allowed to do as you pass through those points. So like at -2, -1, my railroad is going through that dot at a slope of -2. So it tells me where I'm at, and it tells me what my slope is at that moment. I keep talking about the railroad. Another idea that you could do is you could kind of think about it as dropping a ball in a magnetic field. So if I drop the ball at -2, -1, and there, let's say the ball's a positive charge, and there's all these positive and negative charges laid out on the grid, it's going to follow a path because it's going through the charges, okay? Or maybe this is a gravitational pull, or maybe it is, I don't know, what else could it be? It is, I don't know. I'm tired. It's 4:40 in the afternoon, so sorry about that. Let's go with the railroad car. You're designing a railroad track. You have to go through the town -2, -1, but the track has to follow the slope field, or it has to follow this terrain. Okay, the ground sets up this terrain that I have to go at a -2 slope. I have to go flat. I have to go back up. All of the blue ticks are showing me the terrain of the layout of the map, and those are the only ways I can flow through the map. Questions? If you have them, I can't answer them right now. So maybe the sub knows, or maybe you can talk to others. Okay, in the next video, I want you to, well, actually in this video, hit pause after you create the dy dx's for the other 3 that we haven't done. I want you to do those on your own, and then we're going to take a look at them on the next couple slides. So right now, hit pause on the video and try these next 3 out, and then I will reveal to you how I did it, and then we'll kind of go from there. So right now, you're just setting up the tick marks. You're kind of setting up the blue. Don't worry about specific points yet. Just set up the blue. Hit pause now. All right, so this one I have is the dy dx is x squared. Okay, so any path that I choose would look something flat, back up. It would look something really steep, flat, back up. And let's say I want to go through 0, 1. It should look something like that. Before I jump right into it, hopefully you have the right thing. The big thing to notice is, again, it's the same idea. Everything's in terms of x. So everything on that row is where x is 0, and 0 squared is 0. Everything on that row, x is 1, and 1 squared is 1. Where everything on this row, x is -1, but you square it and you get a +1. So things on the right happen to be the exact same kind of ticks on the left. Now, if I wanted to do this, I would go, okay, all of these kind of look cubic to me. So we're going to try the cubic equation, and you're going to see that when I integrate this. So when I integrate, I'm going to move the dx over. I'm going to multiply by dx. I get dy is x squared dx. And we're going to integrate. The integral of 1 dy is y. The integral of x squared is 1/3 x cubed plus c. And like I said, all of those paths looked cubic, and they were. Now, though, if I want to go through 0, 1, I got to plug in 0 and the 1. So I got 1 equals 1/3 0 cubed plus c. So 1 equals c. So that path is 1/3 x cubed plus 1. So the blue tick marks reveal the terrain, the slope of the terrain of, let's say, between Fort Collins and Greeley, and these are the only ways you can design railroad tracks connecting the cities. And it has to be this sort of cubic looking notation. And Fort Collins is at the point 0, 1. So if I want the specific railroad track path through 0, 1, it would be 1/3 x cubed plus 1. Okay. Just looking at the other ticks here, on the next ones, the dy dx equals y. Everything is in terms of y. So that means everything here has to have the same slope. So everything there, y is 1. So everything has a slope of 1. Everything here is y is 2. Everything has a slope of 2. Everything here is -1. So it has a slope of -1. Okay. So this is interesting. If you ever start on the ground, let's say your railroad car starts there, it is going to be forced, because it's slope of 0 to here, 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 slope of 0 to there. It can't leave the ground. It's at the train depot. It's just stuck there. But if I ever start you a little bit above it, then I will be able to shoot up. Or if I start you just a little bit below it, the slopes are all negative and it shoots you down. We're going to look at this one a little bit more on the next video so you can see how I can get the black, the green, and the red.